Okay, so welcome back. This is the challenge for chapter 6. So you went through 6.1, 6.2, 6.3, uh, and took your quiz, and this is an opportunity for you guys to earn some more points. Um, Now we're going to discuss some things that we've talked about already, and also some new ideas that kind of further our knowledge with absolute value functions and any functions in general. This is just one of the functions that we're going to be talking about through Algebra 1, which is similar to a function that we will be dealing with in the near future, which is a quadratic function. Okay, so if I have y equals, the function y equals 1/3, um, that times the absolute value of x minus 3. We learned how to graph this. All right, so if I was going to graph this using our form of graphing, we went through to find the vertex. Right? We found the vertex and we found the slope of either side of your absolute value graph. So if we're going to do it that way, our vertex is going to be h comma k. So if we look at the general form of um, an absolute value graph, it's going to be y equals a times the absolute value of x minus h plus k. Okay, where our h value is going to be our x coordinate of our vertex, and our k value is going to be our y value of our vertex. So looking at this first problem, we're going to say, okay, well, our h value is what's inside the absolute value bracket. So what's inside the absolute value brackets is um, x minus 3. And looking here, it's just the h value. So if we see a minus here, it's actually opposite of what you see. So the the h value is actually just 3, right? Just 3. So our vertex is going to be just 3. Good. Now our k value is what's on the outside, what's adding or subtracting. Now, do you see anything being added or subtracted in this case? No, there's not a number there, but if you don't see a number and you're adding or subtracting that number, that's like saying a 0. So if I was going to add or subtract a 0, it would look something like that. So our k value in this case would be 0. So our vertex for this function would be 3, comma 0, and if I was going to plot that point will look like 1, 2, 3, right there. Okay, so we look at our point right there, and that is our vertex. That's where our graph is going to come to a V. Now, looking at this function, what's in front of what is being multiplied, or in front of the absolute value brackets, is going to be our slope. In this case, our slope is going to be 1/3. So if our slope is 1/3, or our a value is 1/3, that means from the vertex, I am going to rise 1, run 3. So what that means is I am going to, let me get a pen here. So I am going to rise 1 and then run 3. 1, 2, 3. For my second point. And then I'm going to go back to my vertex. I'm going to rise 1, and then I got to run the other way 3. So it's going to be 1, 2, 3. So I'm going to go ahead and graph that line that looks something like that. Awesome. Now, that's something that we've done before, and that's something that you guys could kind of go through real quick and do. The only other thing that new that you'll see with this challenge is talking about the domain. So our domain, if you remember, are all of our x values. Okay, so all of our x values. Oop, that's not what I wanted to do. Back. Let me get a pen here. Pen. Good. So I'm talking about all my x values, and my range, I'm talking about all my y values. So I'm talking about all my x values. I'm saying, okay, in this graph, I could plug in any x value and get an output. So if you see these arrows, that means that my x values are going to go on and on and on and on and on and on and on forever, where I'll always have a y value. And that goes the same in the other direction. So I could keep going on and on and on and on and on and on to negative infinity, and I'm going to always have an output value. So for most of these functions that we're dealing with, the domain is always going to be, I'll just say all real numbers. Um, so I will say all real numbers or infinite many solutions. I'll just say all real, and we'll do an R um, that looks something like that. Okay, so that means all real numbers. Now our range is something different. Now, our range is going to be an inequality in this case, and we kind of talked about this last chapter. So now looking at our graph, does this graph have a maximum point or a minimum point? A maximum point or a minimum point? If you're looking at it and you think a minimum point, that's good. So this is like a pool. So a minimum point at the bottom is going to be there, and it would be, if it was flipped upside down, if the graph went up and down, it would have a maximum point, and that peak would be the maximum point. But in this case, we're talking about a minimum point. If I grab my highlighter, and let's go with that highlighter, and let's talk about all my y values and where this graph is above. So I'm just going to kind of box that in. Now, that graph is above the minimum point or below the minimum point. In this case, that point the graph is above that minimum point, and that minimum point, we're talking about the y values, is all the way at what point? The y is 0. So now I'm talking about so my graph consists of all my y values, that are greater than or equal to what value? In this case, it's going to be 0. Now, if this graph would drop down to -1, I would say all my y values that are greater than or equal to -1. Now, if this was a maximum point and my peak was up here, I would talk about all my y values that are less than, because my graph is below that boxed in point. Okay, so if you have any questions, you could ask me as well as I walk around the room. But I would want you to go through and try number 2 and number 3. I would want you to graph, tell me what the vertex is, and go through and tell me what the domain and range are. Pause the video, work through those two. Once you're done with those two, get them checked by me, and then move on to the next section. Thank you. Okay, so now we're going to be working on something that we haven't seen before, but it might be a little bit challenging until you kind of get the hang of it. So now I have a graph. What's different about these examples compared to the last couple of examples is that my absolute value graph is already graphed for me. So since my graph is already graphed for me, what am I missing? What am I missing? Well, if you read the directions, it says write an equation. Okay, write an equation. So if I want to write an equation for this, I need something that says, okay, y equals. Well, let's undo that and let's try this again. So y equals. Good. So if I have y equals, it's gonna have my absolute value. Now, it's going to look like, if you remember, my general form is y equals a times the absolute value of x minus h plus k. So what I need is I need my a value, I need my h value, I need my k value. But if you remember, my vertex is going to be h comma k. So if I find out what my vertex is, I'm going to kind of knock out 2 of them to begin with. So if I look at my vertex right here is actually 1, 2, 3. So it's actually 3 comma 0. Would you agree? So I would say that that point is going to be 3 comma 0. Okay, so what's my h value? Well, my h value is going to be, oh, no, that's not what I want. I don't want the creative pen, I want the highlighter. So my h value here, okay, is my 3. Okay, and then my k value is going to be my 0. Okay, so my h value is my 3, my k value is going to be my 0. So now all I'm missing is my a value. So when I talk about my a value, I talk about my slope. So if you look at this slope, it looks like that to get from one point to another point, I have to go ahead and plot the next point I see on my graph. The clean point. A clean point means a point that goes through all four corners of a box. Well, if I look, I would say that point goes through all four corners of a box. So from here, I would say, okay, well, how do I get to that point? Well, I'm going to rise one, run one. Okay, so if I rise one, run one, my A value is actually just going to be 1. So if I were to write an equation, I have my A value, I have my H value, I have my K value. All you have to do is plug it into this equation. So it's going to be, in this case, I'll say y equals 1. Okay, I'm going to draw my absolute value brackets in a different color. Okay, times the absolute value of x. Okay, x minus, what's my h value in this case? My h value is 3. And I want black, and I'm going to close my absolute value brackets, and then I'm just going to add my k value, which is 0. I could say plus 0, or I don't even need it. So actually my equation of this, I don't need though actually to write the 1, and I don't actually need to write the 0. I could if I wanted to, but I don't have to. In this case, I would say y equals the absolute value of x minus 3. Oh, let's kind of go back. X minus 3. Good. Alright, so that would be my answer to write my equation. So let's look at that. So that would be my answer right there. Good. And let's go through and from the last couple examples, I would just want you to write your domain and your range for this example, and it would be actually very similar to the one we just talked through before, which is talking about our x value. Since these arrows go on and on and on forever, my domain is going to be all real numbers, okay, and my range is going to be all my y values. Now if I get my highlighter, let's box this in here. Okay, now this graph is above, so I'm talking about all my y values that are greater than or equal to what value of y, and that is 0. Okay, so you're going to need 3 things for these examples. So you're going to need my equation, okay? Sorry, 4 things. You need my equation, you're going to need my domain, okay? My domain, you're going to need my range, okay? And then you're going to need my vertex. Okay, those 4 things. All right, if you have any questions, please flag me down if you need me. All right, see you next time. Thank you. Bye.